All right, so one of the questions, these are all computation, these are not multiple choice, this is computation for the exam. One of the test questions involve what's called a double displacement reaction. So for this, you'll need to bring in your solubility table. So I have my solubility table. Okay, I'll try to bring extra copies, so make sure you bring this. You do not need to memorize it. If anything you want to memorize, you should memorize these 4 words. Okay, all nitrates are soluble, so any type of nitrate will automatically dissolve in water. Okay, all these other things, don't memorize it. Bring this to the test. Okay. So there's 2 parts to this problem. One, you have to write the molecular equation, and then the final net ionic equation to get full points. All right. So first we have to predict the products. Okay, NaI, this is sodium iodide, and KNO3, this is potassium nitrate. Yeah, bring it. Come on up. Okay, come on down. Okay. Ever watched the game show Price is Right? Come on down. You ever watch Price is Right? Okay. So sodium iodide, aqueous means that it's dissolved in water. Okay, sodium iodide dissolved in water is not sodium iodide. Okay, but in fact, if it's ionic, it breaks the water, which is the solvent in aqueous. The water splits this into individual ions. Okay, so sodium iodide is actually Na plus, okay, plus I minus. Okay, what do we know about all nitrates? Okay. Soluble, so they'll break down into K plus NO3 minus. So the way we like to do this is outer and inner. Okay, so we'll do outer. This is sodium nitrate. What do we know about all nitrates? Soluble. Okay, so here I'm going to write NaNO3 aqueous. Okay. Okay, plus the inner, so potassium iodide. Okay, potassium iodide. So what do we know about potassium iodide? All chlorides, bromides, and iodides are soluble except Ag plus, Pb plus, Hg2 plus 2, PbCl2 is slightly soluble in cold water, blah, blah, blah. Okay, so would this be soluble or insoluble? Soluble? So if it's soluble, this is interesting. We never came across this in our lecture notes. This too will be broken down into its ions. So we have NaNO3 aqueous plus potassium iodide aqueous. Okay. So these spectator ions cancel. Okay, these are called spectator ions, right? Spectator ions, they cancel. So what we have here is the molecular equation. Okay. So what would our net ionic equations be, however? no reaction. So you would write this again for the net ionic. Okay, this here's the molecular equation. The net ionic would be, just write our reactants again. And then you would write NR, okay, for no reaction. So these are the two answers to this test question. Okay, no reaction. Okay, so can we do this on a test? Okay. Okay, there'll be like two problems like this, two of them, all right? So if you get no reaction, are we going to panic? No, we'll just write this, okay? No reaction. NR means no reaction. What does no reaction mean? No precipitate. Very good, David. There is no precipitate. Remember the lab we did? Was it last week? Okay. Okay. There are some that just we didn't see anything happen. Okay, those that you didn't see anything happen were no reaction. That doesn't mean that there was no reaction. It just means that the reaction was all dissolved in water and you don't see it with your eyes. That's what it means. All right, any questions or comments on this? All right, so make sure you bring this to the test. Okay. Bring to exam. All right, let's do a limiting reactant problem here. All right, how many grams of nitrogen gas are formed when 97.5 grams of N2H4 and 114.26 grams of N2O4 are mixed? Right, so first thing they're asking for is the limiting, the excess, theoretical, and percent yield. Okay, so the first step in this is make sure you balance your equation. Okay, balance the equation. So are we balanced here? 4, 6, 4, 8, 8, 4 oxygens, 4. Okay, so we're balanced. So what's the limiting reagent? Which do you want to look up? N2 gas or water? Okay, we can do water or N2 gas, it doesn't matter. So I will determine the amount of N2 gas as the product. Remember, these two here are our products. Okay, and these two here are our reactants. So pick a product. Any product, we'll pick N2 gas. So how much N2 gas is made when all the N2H4 is used up? How much N2 gas, I'm sorry. N2 gas is made. All right, so we're starting out with 97.5 grams of N2H4. Okay, let's go ahead and convert that to moles of N2H4. Okay, so what's the molecular weight of N2H4? Okay, nitrogen N2, Nitrogen is about 14.01, but we have 2 of it. Hydrogen is 1.01, but we have 4 of it. So I am getting 32.06. So 1 mole of N2O4 is about 32.06 grams of N2H4. Okay, so for every 2 moles of N2H4, there's 3 moles of N2 gas. For every 2 moles of N2H4, okay, this is why we balance, there's 3 moles of N2 gas. And let's go ahead and do an extension and convert it to grams. For every 1 mole of N2 gas, there's about 28.02 grams of N2 gas. Let's cancel out our units. The grams cancel, moles cancel, moles of N2 cancel. So I have 97.5 times 3 times 28.02. $97.5 times 3 times 28.02. Okay, divide this by 32.06 times 2. Divide by 32.06 times 2. 127.8. 127.8 grams of N2 made product. Okay. All right, now we'll do the same thing. We'll do this in all right, let's look at N2O4 here. How much N2, here I did it again. How much N2 gas is made? Okay, when all the N2O4 is used up. Okay, how much of this is made? Okay, when all this reactant is used up. Okay, so we have 114.6 grams of N2O4. Let's go ahead and convert that to moles. 1 mole of N2O4. Okay, and let's do that really quickly here. N2O4. N2 is about 28.02. Oxygen is about 4, so what's 16.01 times 4? 64.04? Okay. Get about 92.06 grams. So 1 mole of N2O4 is 92.06 grams of N2O4. For every 3 moles of N2, there is 1 mole of N2O4. And for every 1 mole of N2, there's about 28.02 grams of N2. Okay. So the grams and grams of N2O4 cancel. The moles and moles of N2O4 cancel. The moles of N2 cancels out with the moles of N2. Let's do this quickly on our calculator. 114.6 times 3. Times 28.02. Okay, divided by 92.06. Getting about 104.64. 104.6 grams of N2 product is made. All right, so which is our limiting reactant? Okay, reagent, reactant, it's the same thing. Which one is limiting? The one that produces 104 grams of product or one that produces 127 grams of product? Okay, 104. So which reactant, after it's all used up, will give you 104, and that's N2O4. See, you cannot make 127.8 grams of N2 product. Why? Because after 104 grams of N2 product is made, this reactant is used up. It's gone. It's consumed. It's all over. Okay. So our limiting, okay, this product is 104.6 is made when, and then all of this is gone. So you can't make this because this other reactant is all gone. So the limiting is N2O4. The excess is the other one, which is N2H4. And what is the theoretical yield? Okay, how much can you actually make? 104.6 grams of product. And what is the percent yield? Okay, in theory we make 104.6 in theory, but stuff spills. You can't get everything out of the filter paper, whatever. So many things are happening, and so it's hard to collect 100%. So we actually did, or in this problem they did the reaction, they got 90 grams. We'll call 90 grams the actual yield. So our actual yield is 90 grams. And our theoretical yield calculated here, in theory, we can make 104.6 grams if everything were so perfect. And then what is this on our calculator? Okay, don't forget to times 100 to make it into a percent. You guys got 86 something percent? We'll go with 86%. So that is a limiting reactant problem. All right, so these are the steps you have to go through. Okay, make sure your equation is balanced. If it's not balanced, then, you know, this step in the reaction is wrong. Okay, so this is why we balance the equation. All right, any questions on this? So there'll be a problem like this on the test, okay? Okay, very similar to this on the exam. All right, so we move on, okay? So the faster we get through this review, the more time we'll have for studying or other things. Okay, let's do a third problem here. Do you remember your dilutions? Okay. Okay, so we're going to make a solution. Okay, we'll make a solution. We'll make a solution by diluting from stock. Okay, stock. Okay, so we're going to make a solution by diluting from stock. Let me finish this up here. Make a solution. Okay, by diluting from stock. All right, so this practice problem number 3. How will you make 125 ml of a 0.115 molar solution of Na2SO4? By the way, on the exam, let's just sidetrack for a little bit. Okay, what are the units of molar? Okay, if that was a multiple choice question, what would you write? Molar. What would it be? It'll be what over what? Moles per liter is right, but let's be more specific than that. Moles of solute over liter of solution. All right, so this is an important concept whenever you, actually if you work in a lab or higher level chemistry classes, okay, when you're making solutions, you work in a hospital lab, okay, everything is moles over liter. Forensics lab, okay, moles over liter, and that's M. This is called molarity or molar. All right, so back to this problem, how will you make 125 ml of a 0.115 molar solution when you have a bottle in the lab that has a concentration of 1.75 molar Na2SO4? Okay, we're going to call this stock. Okay, what we have already available, this is called the stock solution, what we have already available. So diluting from 1.75, we want to make 0.115, and how much of that do we want to make? 125 ml. So we'll do M1 V1 equals M2 V2. Okay. So molar 1. So usually on the left-hand side is the stock, and then on the right-hand side is the diluted solution we want to make. The diluted solution we want to make. Okay, our stock is 1.75 molar. Okay, so out of that we'll take a certain volume from the stock. How much? And then we're going to make a new solution whose diluted concentration is 0.115 moles over liter, and our total volume, we want to make 125 mils of this, 125 ml. All right, so we'll solve for V1 here. 0.115 molar times 125 mils, okay, divided by 1.75 molar. All right, the moles over liter big M cancels out moles over liter big M. Okay, so 0.115 times 125 divided by 1.75, 8.21 mils. Right, so the answer here is going to be how will you make this? How? Okay, we will take 8.21 mils from the 1.75 molar stock solution. Okay, take 8.21 mils out of that. Into a new beaker or a new flask. Okay, and plus how much water? How much water do we get out? Yes, 125 minus 8.21. Very good. $117. About 117 mils. Deionized water into the bottle. So this is the dilution. All right, we have 2 more computation problems to do. How are we on time here? We got 4 more minutes. Let's see if we can do one more. Go ahead.
For that last problem, would it say M1, G1, would it say that on the test? Would you do that?
Yeah, but I think you should memorize it.
Okay.
M1 V1 equals M2 V2. But it will be given, yeah. Okay. Any other questions? So yes, this will be given, but it's good to know this equation for, future reference. All right, let's quickly take this problem here. This is plug and play. Okay, calculate the density of SO2 gas at 25 degrees C and 0.850 atmospheres. Okay. So remember what density is? Mass over volume. So all we have to do here is take our pressure, which is 0.850 atmospheres. Okay, the molecular weight. What is the molecular weight of SO2 gas? What is sulfur here? 32? Okay. So S would be about 32.06. Okay, oxygen is about 16. 16 times 2 be 32.02. Okay. So about 64.08 grams. So get your periodic table also for the exam. Per mole. This is the molecular weight. Okay, this is the pressure. R is 0.0821 liters times atmosphere. Mole over Kelvin, actually, we'll just go here, mole over Kelvin. Okay. And then T. T is temperature, okay? And the temperature we wanted at Kelvin. Okay, so 273 would be 298 Kelvin, okay? And this is just plug in and play it out to Kelvin. Kelvin cancels, moles cancels, ATM cancels. We get mass in grams over volume in liters, and this will be the answer. So 0.850 times 64.08 divided by parentheses 0.0821 times 298, close the parentheses, and then 2.22, 2.23 grams over a liter. Remember, mass over volume is density. So 2.23 grams over a liter. Okay, so that's the density of SO2 gas at this temperature and pressure. Okay, make sure you put it in Kelvin. All right, so a problem like this on the test where you just plug and play. You plug it in and put the answer out. All right, we will finish this up and then start chapter 6 on Thursday. Okay, we have a lab today. If you have me for lab, I'll see you in lab.